So in lesson 2.4, we're talking about using the rational root theorem and some of the other theorems from Algebra 2 to find all of the zeros for a polynomial function and even to write them in factored form. Today we're going to be looking at doing that with factors that are irrational, which we had that kind of before, but also complex. And we're also going to be talking about writing them in factored form, like actually building equations, which we've done before, but we didn't do it with irrational or complex. So just to review a little bit of stuff that you should know from Algebra 2 and some stuff that we talked, the fundamental algebra theorem, what it basically says is whatever the degree of the polynomial, there should be that many zeros. That many zeros or that many intercept, not necessarily intercept, but that many zeros or that many roots to the equation when we solve it. So it has exactly n of them. Some of them might have multiplicity, which is why we don't see the same quantity. Some of them might be imaginary, which is why we may not see them on the x-axis. But they do exist, and we need to find all of them. The linear factorization theorem says that if f of x is a polynomial function with degree bigger than 0, which otherwise it wouldn't be a polynomial function, then f has exactly n linear factors. So again, it has the same number of zeros. We could actually write those as linear factors, even the irrational and the complex ones, the imaginary ones. And so we will be looking at that today once it's once we've got all the zeros, writing it in linear factorization form. Yes, sir. I do in the front bin. You can grab it from there. Let me do this. Let me just make sure it's recording still. We'll blow this up. All right. So the first skill, and you did this in Algebra 2. I'm going to do this first skill in two different ways. And I'm going to focus on this first problem to start. Actually, we're going to do the middle problem to start. I'm going to do both of these in two different ways, and then I'm going to let you pick the way you want to do it on your own. This is where I said I'm not sure that I left you enough room on your paper, so that you might want a spare sheet of paper. So we have two skills today. One is finding all of the zeros, no matter what the degree of the polynomial is, including all the irrational and imaginary ones, and listing them as linear factors. And the other one is building equations that involve some of those irrational roots and complex. I skipped something on the other page, and that was that our rational zeros happen as singletons. Unless they tell us that there's multiplicity, they're singletons. Our irrational, which would include our complex, our imaginary, because it's the square root of -1. So our irrational come in pairs, like a plus or minus b square roots of c, or a plus or minus bi. So irrational and imaginary. They come in pairs. So if I give you just one, you know there's actually two. I'm going to show you the way that you learn in Algebra 2 first, and if you like that way best, this is where I have my extra sheet of paper because I'm going to need space. I'm going to do this problem one of two ways. So I have the following roots. This one, there should be two of them, right, because it's supposed to come in pairs. So I have the positive 2 square roots of 3 and the negative 2 square roots of 3. And then I have the x equals 1 plus I and x equals 1 minus I, because the complex and the irrational should come in pairs. Any questions on that? So what degree polynomial should this build? What degree polynomial? X to the fourth. I'm expecting a fourth degree polynomial when I'm done. So I should see x to the fourth in my equation. All right, so the way that you did this in Algebra 2, and I'm going to show you a little trick that some of you might like, some of you might not like it. We're going to do the way from Algebra 2 first. The way we did this in Algebra 2 was just like we did with our rational zeros, get them equal to 0. So in this case, I would subtract the 2 square roots of 3, and here I would add the 2 square roots of 3 to get those factors. So I'd multiply these together, and then I'll have to multiply these also, but I'm going to write them down and do them separately first. This one I'd have to subtract 1 and subtract I. This one I'd have to subtract 1 and add I. I really don't like multiplying trinomials. I can do it, I just don't like it. And I don't even like multiplying things that have square roots. And so that I don't have to think about distributing and focusing on all that, I like to use the box method for multiplication. You don't have to. You can still just do regular distribution if you want. So this one I'll need a 3 by 3 because I have 3 terms and 3 terms. So on the one on the left, I have x minus 2 square roots of 3. And I have x plus 2 square roots of 3. X times x is x squared. X times negative 2 square roots of 3 is negative 2x square roots of 3. So I'm just multiplying this one in this row by this number in this column. It's like a multiplication table. This times x is positive 2x square roots of 3. And I'm glad that I have that. Why? Why am I glad I have that? They're opposites, so they're gone. That's nice. When I multiply this is really negative 2 times 2 is negative 4. Square root of 3 times square root of 3 is 3, so that becomes negative 12. Any questions on that? So the product of those two right there, from those two irrational roots, is x squared minus 12. And if I wasn't sure if I did it right, I could actually solve. Set this equal to 0, add 12, take the square root. You would get plus or minus 2 square roots of 3. So that's how I know I did it right. For my other one, which is x minus 1 minus I, and x minus 1 plus I, so I put this one down and this one across, I would get x squared minus x minus xi, or ix, it should probably be ix, I don't care, minus x plus 1, negative 1 times negative I is positive I, plus plus ix minus I. Now this last one's the tricky one. What is I times I? I squared, which is negative 1. So negative 1. If there was a number in front of it, then I'd multiply that number by negative 1. Well, this also worked out nicely because my negative I and my positive I are opposites. They cancel out. My ix and my negative ix cancel out. And when you do this, if you do it correctly, all the i's should disappear. When you do this, if you do it correctly, all the radicals should disappear. So now I just have to combine like terms. I've got x squared minus 2x. I've got 1 and negative 1. Wait, something's wrong. Oh, yeah, that was a negative I times I. So this was negative I squared, right? So if it's negative I squared and I squared is negative 1, right, then I have negative times negative, which makes it a positive 1, sorry. Be careful about that. I didn't see the negative up there. So that makes this plus 2, because otherwise it wouldn't work. Again, if you're not sure, you could solve this using the quadratic formula because it's not factorable, and see that you get these roots back. Any questions on what we did so far? But wait, there's more, because we were supposed to multiply all 4 factors together. Right now I just did those irrational and these complex. So now I have to do x squared minus 12 times x squared minus 2x plus 2. I don't mind distributing this so much unless it's 2 trinomials, so I'm just going to go with distribution. If you like box method, you can use that too. So this gives me x to the 4th minus 2x cubed plus 2x squared. This gives me minus 12x squared plus 24x minus 24. So I now have as my final answer for that problem that we did at the top of the page, or that's at I'll write the answer now in a second, x to the 4th minus 2x cubed minus 10x. This was supposed to be, wasn't that supposed to be squared? Yes, it was. 10x squared plus 24x minus 24. So that's the answer. Now, if I put that in my calculator, I should see these roots. If I were to do the find the 0 on the calculator, use second trace to get the 0, the decimal value of this should appear as my two zeros. I won't see the complex or imaginary ones, though. I'll only see the irrational ones on there. But I should get that. So the answer to this we said was x to the 4th minus 2x cubed minus 10x squared plus 24x minus 24. And I have all the work shown on this other piece of paper. I'm going to show you a way that helps you avoid having to expand this and leads you straight to these two equations still. So you'd still do these products, but you don't have to think about both of these roots and both of these roots. And so that way is to do the following. See this right here, x squared minus 12? You don't have to write this part down right now, but if I were solving x squared minus 12, what would I do first? Add 12. So I'd get x squared equals 12. Now I'd take the square root. I'd have plus or minus the square root of 12. And I'd break that down to 4 and 3, which is 2 square roots of 3, right? Well, rather than write that out as linear factors and multiply them together, I just reverse this process. I say, hey, you give me this, and if I know that it's plus or minus, then I know the last thing you did was took the square root. As long as I get it down to the plus or minus, I know the last thing you did was the square root. So I'm going to square both sides. That's going to take me to x squared equals 12. And then I can write that by setting it equal to 0, or getting it equal to 0 as x squared minus 12. I don't have to go through the whole process of distribution. So I will show you how I do that with this particular example. If you like it, you can use it as long as you're getting them right. If you don't like it, you can do it the way we did before, the same way you did in Algebra 2. So knowing that there's 2 for this, I start this problem. You can just follow along for now if you want, or write it down. It's up to you. 2 square roots of 3. My other one is x equals 1 plus or minus I. It's the imaginary part and the radical part that get the plus or minus. The number in front stays the same sign. In this one, you're going to do what we just said. You got down to plus or minus, so square both sides. X squared equals, well, 2 squared is 4, and square root of 3 squared is 3. So that's going to be 12. When you square it, you drop your plus or minus. Why? What is positive squared is positive, and negative squared is positive. So I've got x squared equals 12. So now it's just x squared minus 12 as my factor. To me, this is less work. This is easier. But to some of you, you might not like it. For this one, I have to get it down to the plus or minus, so I'm going to have to subtract 1 from both sides. So I have x minus 1 equals plus or minus I. I'm still, unfortunately, going to have to do some distributing with this one because I need to square both sides. And what is I squared? Negative 1. X minus 1 is x squared is x minus 1 by x minus 1, which we know is x squared minus 2x plus 1. To get this one equal to 0, I'd add 1 to both sides. So I would have x squared minus 2x plus 2, which these are the same factors I had when we did this problem the other way. So if I now multiply these two together, I'm not going to go through that again. But if I multiply these two together, I will get this answer again. To me, this is easier. It's less work. But if you're struggling with doing it this way, then just go back to the way that you've always done it. Okay? So we're going to try this for the problem on the left. I'm going to try it this way. If you don't like it this way, go back to the other way. So I have x equals negative 1. That's a singleton. X equals 2. That's a singleton. 2 minus I is actually 2 plus or minus I. What degree polynomial do I expect for this? 4th degree again. Because I have 2 roots here. the 2 imaginary, and 2 rational roots right there. So this factor is going to be x plus 1. This one's going to be x minus 2. I'm going to multiply those two together right now because that's easy enough. I've got x squared minus 2x plus x is going to be minus x minus 2. This one, rather than writing out the factors, but you can do it that way if you like it to, I'm going to have x minus 2 equals plus or minus I. I just took away the 2 from both sides. Now to get rid of the plus or minus, I'm going to square both sides. I squared is negative 1. X minus 2 squared is x squared minus 4x plus 4. So that becomes, when I add 1 to both sides, x squared minus 4x plus 5. Any questions so far? All right, now again, it's 2 trinomials. If you want, you're welcome to just do distributing this 3 times, this 3 times, this 3 times, and combine like terms. Once I get to 2 trinomials or higher, I like to use a box for my multiplication table. So I'll put my x squared minus 4x plus 5 here. You could put it the other way if you want. And my x squared minus x minus 2 here. So now I have x to the 4th, negative 4x cubed, positive 5x squared, negative x cubed, positive 4x squared, negative 5x, negative 2x squared, positive 8x, and negative 10. Going to combine like terms, I get x to the 4th minus 5x cubed. That's 9 minus 2 is minus 7x squared. That's plus 3x. Is it positive? Thank you. Positive 7x squared. Positive 3x and minus 10. So there's my quartic equation that I built from those zeros. Any questions on that? All right. If you don't like doing it this method, you could I'm not going to do it right now, but you could do this as x minus 2 minus I and x minus 2 plus I, and distribute those, you would still get right back to here. And then you'd multiply it out. So you can use either method as long as it works for you. We're going to set up the problem for the one on the right side, and then I would like you to try that problem, like multiplying it out and seeing what you get. So basically, because the negative 2 has multiplicity, I have the following factors. X equals negative 2, but I have it 2 times, because it has multiplicity of 2. I have x equals 0. And how many factors am I going to get from the 3i? 2. It's going to be plus or minus 3i. If you like to separate it, you could do x equals 3i and x equals negative 3i and do it that way. I would put these two, once you have their factors, I'd multiply those together, and then I would distribute in the x. And here you can decide how you want to do it to get your factors from these two. So see if you can do that right now. Give that problem a try. Just try to figure out what the product of those 3 is and what this would be. Don't do the final equation yet.